Hello, welcome to Notes 3.07. So we are going to be doing 3.07, but before that, I would like to finish up the classwork from 3.06. There was some important information here, and there's an extra proof at the bottom that I think is worth talking about today. So with the first picture, we want to be looking here at the given. So again, this is the back of 3.06b if you're looking for this in your packet. But given D is the midpoint of EC in the diagram below, that information needs to be marked in your diagrams. So D is the midpoint of EC, making DE and DC equal. In the diagram below, also, AE is congruent to BC. Well, that's already here marked for us. So that's where our single dashes are. And lastly, sorry about that, angle 1 is congruent to angle 2. So by those three markings, again, remember, and I've been using a Post-it note for some of us to cover up one of the two triangles. So we mark both triangles, but when we're deciding that method of congruence, the side, 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 angle, angle, side, or HL, we want to only focus on one picture at a time. So we look at the markings. This is the marking for a side, an angle, a side. So what method would you use to prove them congruent? Side, angle, side. It's not right triangles. They didn't tell us these were right angles, just that they were equal. So remember not to make those assumptions. Now that these two triangles are congruent, so what that says is this triangle and this triangle are of equal measures and size. That if I reflect this triangle over, right, that angle 3 and angle 4 are what's called corresponding angles. So with corresponding angles, those angles are going to be equal to each other. So here in the diagram, if they gave you the measure of angle 3 and angle 4 were those two expressions, those would be equal. Now here, I guess I did leave it as 1 and 2, that we knew 1 and 2 were congruent. So if the measure of angle 1 and the measure of angle 2 are x squared and 7x minus 10, then those things are equal to each other. So x squared equals 7x minus 10. I would like you to solve this. If you want to pause the video to do it, I'm just going to not talk and do the math here for you. I ran out of space a little bit there, but we did need to multiply to a positive 10 and add to a negative 7. So they're the same signs where negative 5 and negative 2 multiply to positive 10 and add to a negative 7, right? So x is 5 or x is 2. And that's it really there for number 5. Number 6, I'd like you to be marking with me. Again, marking up the pictures with the given information is half of our battle. Then the rest of the proof is going to kind of be put together from there. So AR is perpendicular to CB. When those are perpendicular, we're going to put in those right angles. And I'm automatically going to always put my 1 into it. Also, CR is congruent to BR. So in that case, if C to R is congruent to B to R, that's already kind of marked for us. We have that information here. So again, I know some of you like the color coding. Well, that's all that was given. There's only 2 facts given. But again, our acronyms, side, 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 angle, and so on, they require a third piece. So this is where we're going to pull from our assumption of reflexive property down the middle here. So now our 2 triangles have sides, angles, and sides as congruent. So a reminder, you always cover up one triangle. Focus on one triangle at a time and look at the markings you have. This dash mark is a marking for a side. This marking is for an angle and a side. So these are congruent by side, angle, side congruence. Okay. Therefore, these sides AC, which is 4x plus 8, and AB, which is 7x minus 4, are corresponding sides. So we have corresponding angles here of 3 and 4 in this picture that would be congruent to each other. So those corresponding angles are congruent. Here we have AC and AB are corresponding sides that are congruent. And that idea we're going to come into later this week with our next notes video. So if AC and AB are congruent, then 4x plus 8 equals 7x minus 4. Move your 4x's over to the opposite side. And add 4 over. 12 equals 3x. Ooh, let's try this again, Miss Locke. X equals 4 is the final answer. So that's 5 and 6. Now for a proof. Now some of you did try this and I appreciated that. But again, the process here is you take the given information and we're going to mark up the diagram. So the first piece of the given says BD bisects angle ABC. Now that's going to gain us a set of equal angles. So angle ABC is cut into 2 equal pieces. So we have 2 equal angles here. I'm going to put a 1 and a 2. It's an automatic piece for me. Every time I mark it, I put the 1s and 2s in. Next, they tell us AB is congruent to BC. Now that's a set of sides. It's a segment AB and a segment BC. So AB and BC are equal. So right now it's angles and sides. So I know it's not side, side, side. I know it's not HL, okay? But now we need to look at the picture and decide which property are we going to assume. So this is where we use our reflexive property down the middle. So again, the method of covering up one of the 2 triangles, okay, and look to your markings. Now again, I'm going to start to the top left and kind of go clockwise until I hit the next marking. So we have a side marking, an angle, a side. So mark the diagram to determine the method of congruence. It's going to be side angle, side congruence. So again, we needed that assumption here of that reflexive property. So into the proof, and this is what we're going to be focusing on today, is writing these proofs. Now here, these statements are filled in for us. We always have an introduction, which is a restatement of the given. So notice there's 2 facts in the given. They happen to break them up into 2 lines here. Now they could have reorganized this. They didn't have to make the second piece a statement 2. All right. So what happens with this is I would have lumped all of that into 1 paragraph, and I'm going to explain that with the proofs we're going to do today. What else? Well, this bisector gave us a set of angles. Now I called them 1 and 2 in the picture. So personally, I would have put angle 1 congruent to angle 2. But if you wanted to use the 3-letter combinations, ABD and DBC, you could. Okay. But why, from this angle bisector, are these angles congruent? The reason here is going to be by definition of bisector. Okay. So going through my proof, again, we decided it was side angle side. So right now we have this set of sides listed as congruent. So we need 3 congruent statements in order to get side angle side congruence. Now we have this set of angles, okay, from that bisector idea. So now we have a congruent statement to have those angles as congruent. Okay. To decide how many steps you need in your proof, we have to do one other piece. So now we need one more fact. We have the sides, we have the angles. We're going to now need one more step here to have that other set of sides that we marked. So X is reflexive. And from our cheat sheet, okay, from this notes 305 here, okay, if you want to pull that out, whenever you have an X marked in the picture, this statement and reason are going to paste into our proof. So here we're going to write that BD is congruent to BD by reflexive property. All right. So again, your proofs aren't complete until you have a set of sides, a set of angles, and the other set of sides. So if I kind of use a third color here, that third set of sides is your reflexive. So we do need these 3 congruent statements. Once you have those, then we're done and ready to end the proof by telling me that triangle ABD and triangle CBD are congruent by side angle side congruence. So we're going to be putting these proofs together over here. So looking at notes 3.07, right? Same process. We're going to, step 1 is to mark your diagram. So I'm going to write mark the picture. Step 2, decide the method, meaning side, 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 angle, side, angle, side, angle, 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 side, or HL. Okay. And then step 3 is to put the proof together. So I'm going to say write proof. Okay. So those are your 3 steps. And we went through those on our last notes page. So looking here at our picture, angle S is congruent to angle V. And I'm going to use my highlighters to try to help here visually with us. So angle S is congruent to angle V. That gives us a set of equal angles. The next piece, SV bisects RU. Now I'm going to read that again actually. Segment SV bisects segment RU. So that gets us a set of sides. And the one that's bisected is R to U. So that's cut into equal pieces. So right now we have angles and sides. So we know it's not side, side, side. We know it's not HL. We don't have right triangles. Now this is where we have to look at the next assumption. So remember, we have reflexive property of the X as one of our assumptions. And we also have these vertical angles. Okay, so just a reminder where to find that. That information we did over here. So we always have reflexive property if they share a side down the middle. Maybe the picture looks like this. Maybe the picture looks like this. Okay, that's when we have our reflexive property. Another assumption is these vertical angles. Okay, so that was back on our last notes page. So looking at our picture here, this is a case for vertical angles. It's that butterfly bow tie picture. Right? So 1 and 2 are congruent. So now we have another set of angles. So we have angle, angle, side, or is it angle, side, angle? So this is where our Post-it note will help. I'm going to cover up one of the 2 triangles. And we're going to just look at this picture. So I know I have 2 angles and a side. So is it angle, angle, side, or is it angle, side, angle? Is the side between them? Well, the side's over here. My 2 angles are here. So the best case is going to be angle, angle, side. So we've decided the method. How we're going to use that method is we're going to organize our proof to have a set of angles as congruent, one angle congruent to another set of angles as congruent, and then a set of sides congruent. Once we have those pieces put in our puzzle, okay, so we're using that as our outline. First piece we need, second piece we need, third piece we need. Then we're going to end the proof with triangle RST is congruent to triangle UVT. Okay, by angle, angle, side congruence. So I kind of have a very rough outline here. We have to decide how many statements and reasons we need with this information. So I kind of left it open. So let's go in and decide how many statements. Well, statement 1 has to have all this information here. Well, they gave us a set of angles. Angle S congruent to angle V. So we're going to write angle S congruent to angle V. But we also need to add in the rest of the given. So we're going to write SV bisects RU. But within that given, we only had 1 congruence statement. Okay. Just going to go back in. My other set of angles here were these vertical angles. So I'm going to try to use the 3 colors to help ourselves, right? So we have the orange statement with the congruent angles, and that all is by the given. So that's our introductory paragraph. We rewrite the whole given as step 1. Now it looks like we need another set of angles. So I'm going to make step 2 be the next set of angles I needed. And then step 3 is going to be the other set of sides I need. So since I only have 1 congruent statement there, I'm going to need 2 more to have the other sets of parts listed as congruent. Then we'll be done with statement 4. Okay? So I'm kind of outlining it first, and then I'm going to backfill what I need. Okay? Well, what other angles were congruent? Well, these other angles I had in pink. So I'm going to go to the pink angles, or angles 1 and 2. Well, why was 1 congruent to 2? because vertical angles are congruent. Next, the sides. So again, we had the orange angles as the first step. Then we pulled from our assumptions and had the pink angles. Now we have the sides that we listed in green are RT and TU. So here we're going to write that RT is congruent to TU. And that reason came from here. What we had in green was definition of bisector. So moving on to proof 2. So again, the process, mark up the picture, decide your method, make sure all the pieces are there. So we have a set of congruent angles, the other set of congruent angles, and then the set of congruent sides. So you know your whole proof is complete if you have 3 congruent statements. So moving down to proof 2. We have to mark up the picture. Now I did fill some of this in already for us, and I'll explain it as we go. Isosceles triangle ABC. Now that tells us a lot of important information. It tells us that a triangle has 2 equal sides. So that isosceles triangle piece gives us a set of sides, AB and BC. It also gives us, and we remember that if we have 2 equal sides, we also have 2 equal base angles. So we're also going to gain a set of angles here, angle A and angle C. So that isosceles triangle piece did give us 2 parts in our picture. Okay. Next, we have an altitude, BD. Now technically, what an altitude is it makes 2 segments perpendicular. So that's a little bit of new information here. So we're going to walk through it. So that altitude gives us perpendicular sides, which gives us those right angles. All right. So here, when BD is listed as an altitude, we're going to have angles 1 and angles 2 is equal. Now I didn't put numbers in at A and C because there's only 1 angle formed at A and C. So moving through my proof, we rewrote the given here. But wait, Miss Locke, we did not make a method of proof yet. So let's look at our markings. We have to isolate 1 picture. Now we have 3 things marked. So I didn't use the reflexive property here for a reason. Okay, I already have 3 items. We only use the reflexive property when we need a 3rd set of parts. So this is the marking for a side. This is the marking for an angle, and this is the marking for an angle. So remember, side angle angle is the same as angle angle side. It's just how you look at the picture, it's a little bit backwards. All right. So that's our method of proof here is going to be angle angle side or side angle angle. So looking through the proof on what they've done right now, they've listed a set of sides. So we're going to have the sides here. Looks like we have a set of angles here, kind of already in our proof. So this given information did not have a congruent statement. So that first set of sides that we marked as orange, AB and BC, are here. AB is congruent to BC. Well, why did we mark that? Because of the isosceles. So here we're going to write isosceles triangle definition. Well, why were angles A and C equal? Well, I marked those in green, and that came from the information I was given with the isosceles triangle. So those angles are congruent, and this is where we use our notes 305 to help. When we're on the isosceles triangle piece, the sides are equal by definition of isosceles. The angles are equal by the isosceles triangle theorem. So this is by the isosceles triangle theorem. What the theorem says is if sides are equal, their opposite angles are equal. Okay, so we've done the orange, now we've done the green. Now we're on to the pink. We need another set of angles here. So this takes about 3 steps to get these angles as congruent. So these 3 lines kind of all go together, steps 4 through 6 here. all right? So these three lines are going to kind of all lump together. Well, altitude makes lines perpendicular. So that's a little key piece here. So the reason we have an altitude, BD, is a segment perpendicular to its opposite side. So that's by the definition of altitude. But these next two lines are what we have on our boxes. So once we have the perpendicular lines stated, now we have 90-degree angles, and then we have angles that are congruent because they're right angles. So how we're going to format the next two pieces is, since I put the 1 and 2 in here, we're going to write the measure of angle 1 is 90, the measure of angle 2 is 90. Perpendicular lines form 90-degree angles. Then the next statement, 6, is going to say that the angles 1 and 2 are congruent because all right angles are congruent. So these statements 5 and 6 kind of go hand in hand, that the measure of angle 1 equals 90 and the measure of angle 2 equals 90 because perpendicular lines form 90-degree angles. Well, if those two angles are each 90 degrees, that's 90 and this is 90, then they're congruent to each other. Angle 1 is congruent to angle 2 because all 90-degree angles are congruent, or all right angles are congruent. I might say this a little different in the next proof that might make sense to some of you, but again, essentially I'm taking these two lines here and pasting them into my proof because I had that perpendicular symbol, okay? Now that we have a set of sides, a set of angles, and a set of angles, these two proofs are congruent by side angle angle congruence, which is again the same as angle angle side. It's just reversed order. We have two more proofs to look at together, and then I'm going to help set you up for a couple proofs on the next page. Okay. Proof 3. PQ is congruent to SR. PQ is congruent to SR. Well, those are sides. So I'm going to mark those and highlight them. QT is perpendicular to PR and SV is perpendicular to VR. So when we have perpendiculars, we're going to highlight those. So QT is perpendicular to PR. That makes right angle here. And SV is perpendicular to PR. Now this is a complex diagram, but there's really multiple sets of congruent triangles, okay? There's this set here, these little corner pieces, and then there's the bigger slivers here and here. If you think about tangrams kind of put together. Now I know we're going to be doing these two triangles, so that's why I'm purposely kind of marking that. Technically, there's another right angle to the other side of V and T, but I only want the one in these little triangles here and here. Okay? Because the next bit of information they give me is that QT is congruent to SV. And this is after multiple years of me doing these and just knowing these proofs that I know to focus on these two triangles. And that's going to come with practice, all right? So those three bits of information, again, if we think about it, gave us a set of sides. Two perpendicular lines made a set of angles, because perpendicular lines form the congruent angles. And QT congruent to SV is another set of sides. So the way they gave it to us, kind of listed out in the given, makes it seem like it's side angle side. But this is where we have to cover up the triangle, isolate one triangle at a time, and look at its markings. Okay. For side angle side, we would need two sides and the angle between them. So between the two sides we've marked, do we have the angle between them? We don't. So it can't be side angle side. Well, we have an angle on two sides, but we have an angle side side. Ooh, angle side side is AS. We can't do AS in math class. So we rename this HL because it is a right triangle. So this is our case for hypotenuse leg congruence. So with HL, what we need to do here is we need to make sure we have the proof kind of laid out to have the hypotenuse and the leg stated. So what I'm going to go through and do is I'm going to re-letter these. So it ends up being, again, angle, side, side, but we can't use AS in math class. So this PQ is actually a hypotenuse. So I didn't know that at the start, but now that I have the right angle put in, I can rename that an H. These still give us the right angles. So we do still need the right angles as like that third piece within our proof. And the last step, SV and QT is going to really be the legs of our right triangles. Okay, so laying out the proof, statement 1, we're going to rewrite that whole given. So PQ is congruent to SR. QT is perpendicular to PR. And also SV is perpendicular to PR. And lastly, QT is congruent to SV. And that's all given. Now I listed it in 3 separate lines, kind of on purpose. I could have renumbered this 1, 2, and 3 because it's 3 bits of important information. And labeled it 1, 2, 3, but I like to put it all together as statement 1. So sometimes you're going to notice the proofs are 7 or 8 steps because they kind of break this piece up. I like to keep it all together, and you can too. Depends on what works for you. All right. But now we have to decide, what do we already have and where do we need to go? Well, we have the H already listed because that was already a congruent statement given to us. We already have the L listed. Now we need to handle the right angles. All right. So we are going to need 2 steps to handle those right angles. All right. The reason being, when we have those perpendicular lines, this is really 2 steps put together. We need to say that each angle is 90 and then the angles are congruent. So we need 2 steps. So that's where I just made a statement 2 and a statement 3 to handle the right angles. Then I'll be done. Then I can call and then get to my proof statement. The end of my proof is the conclusion. The proof piece is going to be statement 4. Okay. So with the right angles, we're going to have that. I'm going to put a big 1 in here and a 2 in here. So if I number them in my picture, I can now use numbers in my proof. That the measure of angle 1 and the measure of angle 2 equal 90. So I kind of restated that a little different here than I did on the other page. The reason being, perpendicular lines form 90-degree angles. That's the technical definition of perpendicular. Perpendicular lines form 90-degree angles. But if both angles are 90 degrees, then they're equal to each other. So that's why we need 2 reasons here. Some of you get that. Some of you will just write it out because I tell you to. Okay. So angles 1 and 2 are congruent because all 90-degree angles are congruent. But now we have the hypotenuse, the legs, and now we have an angle congruent statement. So again, we need 3 congruent statements before we can end our proof. So this conclusion I've kind of skipped over talking about in the other proofs. What we're asked to prove is our conclusion here. Our conclusion needs to end the proof. So how we're going to end the proof is by saying triangle PQT is congruent to triangle RSV because of hypotenuse leg congruence. So that method, this method again is always your last statement. Now each proof I'm kind of bringing in a little bit new information. All right. We had a proof over here with a bisector. We had a proof over here with the isosceles idea and the altitude idea. We have a proof here with perpendiculars again. All right. And we kind of put that together. Now we're going to have a little bit new information, these parallel lines. So we did look at this proof on classwork 306A already. We marked up the picture and decided the method before. But these lines are parallel. That gives us always a set of angles. So parallel lines are going to give you that Z set of angles. So this little angle in at B is angle 1. And then the Z comes down here. This little angle in at D is angle 2. So this information that AB is parallel to DC gives us a set of angles. Next, they give us a congruent statement. side AB is congruent to side CD. So that means these sides are as congruent. So we have angles and sides. We've run out of given information. So now we're going to pull from our two assumptions. Do we have the reflexive property, or do we have vertical angles here? Okay, we have reflexive. There's this X marked down the middle. So we have another set of sides given to us by reflexive. So we're going to cover up one triangle and decide our method of congruence. We have a side marking, we have an angle marking in orange, and another side marking there in pink. So this is going to be the case for side angle side. So now we need to start rewriting our given and see what's here. So statement 1 is rewriting the given. AB is parallel to DC, and AB is congruent to CD. Statement 2. We have to decide what to do next. All right, so we've decided the method, so now we need to kind of look at the pieces. Well, in our congruent statement, we have, or in our given, we have a congruent statement. So that gives us this set of sides. AB is a side, CD is a side. So since we need side angle side, the next step is going to be our angles for step 2. We're going to give a set of angles. Well then, if we've done side and angles, we need another set of sides. So that's where we're going to need 3 steps to handle our 3 congruent statements. Okay. Once we have those parts, we need to get to our proof, our conclusion. Okay, is our last statement. Those are congruent by side angle side. So if you want to fill it in now, you can. I almost like to backfill. Okay, know where I'm going and then make sure I have all the pieces I need. So triangle ABD is congruent to triangle CDB by side angle side congruence. So if it needs to be side angle side congruence, I need a set of sides, I need to write out a set of angles, and I need to write out the other set of sides. So this is where you're going to go to your boxes page. Well, the angles from parallel lines, okay, are over here. So when we have parallel lines given to us, we need to write one of these 3 pieces. Well, we had the Z angles. So those Z angles was this step here. Now in that picture, there was a 3 and a 6. In our Z, we have a 1 and a 2. So we're going to write angle 1 is congruent to angle 2. And the reason is coming directly from here. If lines are parallel, alternate interior angles are congruent. So if lines are parallel, alternate interior angles are congruent. Right. So that's coming from the parallel lines. So when we have parallel lines, we have these alternate interior angles. The alternate interior angles are congruent. We have this line in our proof. Now the other set of sides was the pink X, meaning reflexive. So we haven't had this in the proof yet, but BD is congruent to BD was the line for my reflexive here. So we need something to look like that. So in our picture, it is actually BD. So you use the letters from the picture you have in your proof, remember. It's not always going to be BD and BD, but BD is congruent to BD, and that reason is reflexive property. So again, these reasons come from your notes 3.05 that were really important. So if you've never done that, please do. So we've done 4 proofs today. I know it's a lot of explaining. I want you to try 2 on your own. Right? So looking at your classwork for today, I'm going to help you mark up the pictures. We have already seen these actually, but we're going to do proofs 1 and 2. If you'd like some extra credit and you want to get a little ahead of the game and you want to go on and try proofs 3 and 4 for now, we will do those at a later time. I'm going to start here. This is actually, I'm going to just tell you as a clue, this is a 2-step proof. What I want you to do with this one is mark up the picture. You have 3 congruent statements, okay? So all three congruent statements go in as your given. That's going to give you your sides, angle, side, angles, angle, side, angles, angle, angle, side, something. So mark up the picture to decide the method. Then your proof is your statement 2. And that here, you're going to put that acronym. So in here is going to be side, angle, side, or angle, side, angle, angle, side, or HL. I know it's not side, 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 because I don't have 3 sets of sides. All right. It's really not going to be side, angle, side either. So one of those pieces goes in there. So I want you to try that one all on your own. I'm telling you it's only 2 steps because you do have 3 congruent statements here. Those all just paste into number 1. So that gives you all your pieces. Then you prove it by a method. So all that information is pretty straightforward. The second proof, okay, I'm going to mark up with you, kind of highlight, and then let you fill in the rest of the proof. All right. So AB is perpendicular to BC. AB and BC are perpendicular. So that's going to give me a right angle. 1 right angle. I'm going to put a 1 there. AD is perpendicular to DC. That gives us another right angle here. Let's put a 2 there. Okay. So those 2 statements together give you a set of angles. This angle here and this angle here. Okay. Next, you have a set of sides given to you. AB is congruent to AD. AB and AD is a set of sides. Okay. So we have a set of angles, a set of sides. Then we have to decide what assumption can we make? Is there vertical angles or reflexive property? Because I don't have any more information. I need to see reflexive or vertical angles. And most of you probably already put the X here on your picture. So that reflexive property gives you another set of sides. So you have to decide, is this side, angle, 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 side. All right? And I want you to try to do what you can. Now, statement 1 is all you're given. Statement 2, statement 3, and statement 4 and 5 is what you're going to need to fill in. Okay? So do what you can. This is a puzzle. I want you to put some of the pieces to the puzzle together. A hint here, when you're deciding your method, okay, the S's aren't going to stay S's. Okay, they're going to be changing to other letters. So if you're looking at this proof, I want you to fill in what you can. I'm not going to give you too much more here, but I will tell you this proof number 2 has some similarities to this proof number 3 over here from your notes. Okay, so I'm going to have you write that down. So you're going to see proof number 3 in your notes. All right. So do what you can, submit me. Again, just proofs 1 and 2 here on classwork 307. If you have questions, please email me. We can set up a Google Meet. I can make sure to check in with you before our next class.